So, please, ladies and gentlemen, welcome on stage Jiayi Hu. So Jiayi is a talented speaker since he was 21 years old, maybe. Currently
maybe even 20, yeah.
20 years old, currently working remotely as front-end consultant and trainer. You can find him online on the Italian JS communities. And he enjoys chatting about React, but also Baricco and Murakami. Okay? Have fun.
Okay. Okay. Hello, everyone. Thanks for joining to the conference. And let's get started then immediately. So this talk is going to be about principal patterns in everyday, basically, usage and development of React components. So basically, I joined a company called IBV, where we built a product called Collabor over 1 year and a half ago. And basically, Collabor is software similar to Figma or to Miro, for those of you who know those softwares. Just not as cool as them, but we tried our best and have a customer. We haven't been acquired by Adobe yet, but we are working on it. And so this kind of software is built in React and Canvas. And it's really complex because you can have multiple users interacting with the Canvas. And you need also to integrate not only React, but of course with Canvas, which has, let's say, a very imperative way of being developed. And it's also difficult to make it performant with everything. So this gave me the opportunity to basically think a lot about designing software during the past year. Thank you. And it was a fortunate event that during the last year, I was listening to an interview to Salvatore Sanfilippo, the author of Redis, who was talking about, in general, how to design software, for instance, about the downsides of having bad abstractions. And this is indeed a really good book about programming in general, not specific to JavaScript, but still also pretty modern. I think it was released, published in 2017. And the book defines the terms of complexity, which is basically anything that makes the code hard to understand and modify. When we write code, we often write code basically try to make it maybe clever and short, but unfortunately that kind of code is hard to understand and modify. And throughout this talk, we're going to see different examples in React specifically of code that maybe we used to write or we are writing even nowadays, but it is hard to understand and also to extend and modify. Please also remind that when you write code, there is always someone else who's going to read it first in the pull request review. So it's never only one person working on a code. Yeah. So the two main causes of complexity, there are, of course, different. The two main ones, in my opinion, at least for this talk, are obscurity and lack of good composition. So obscurity means basically just that important information is not obvious, meaning that, for instance, is implicit. And as I said, for instance, it means that during a pull request, you need to know that, for instance, some function is going to work implicitly in some certain way, meaning that if you don't know that, maybe you are not detecting a potential bug. And often, for instance, there are even frameworks which maybe are very interesting at the beginning because they seem to show you how to create an entire application, just a few lines of code. The problem is always then extending the code, and when there are problems, trying to understand exactly what's happening. So sometimes, actually, in the past years, I've actually grew stronger about this opinion. It's better to write more code because more code often is simpler and also reduces cognitive overload. I'm not saying that you need to write like a sum in the 20 lines of code, but generally speaking, especially if the problem of the component, for instance, is complex, it's better to have like a good implementation that takes more lines of code instead of one that tries to solve the problem in a smart way, but really making it hard to later extend it. So you also have to remind the code is maybe written once, but you have it written many more times and also by many more people, especially if you work in bigger teams. So we can start with examples of that, especially in the beginning of React. There has been a component called React Select that is still nowadays very, very popular. And I think many of you have used it at least once in your life. So React Select starts very simple with an example like this one, where you can just define a list of options. But the problem is that when you want to customize it, for instance, you want a sync list of options, and then you jump to the documentation about the props, then you find this page here, where you can see from the scroll bar size that I can spend a whole day scrolling. And I kind of really remember that there was one day I spent like 2 hours scrolling down this list of documentation to find out basically what I need. And this is a perfect example of obscurity, because it means that, for instance, when you are developing component, you don't know for sure what's exactly the good prop to use. And you are always left wondering maybe if there is another prop that works better for what you need, or maybe there are some props that are having conflicts and you even don't know about. Maybe you have used a multiple select, but you are missing another required prop, or you are conflicting with another prop only used for single selection or single selection. So it makes the code really obscure. And this comes from one of the, I think, most popular components in the open source community. But at the same time, I understand that because React Select has been built like from the early stages of React. So many of the popular patterns we use nowadays, like render props, are not supported, for instance, or at least they are supported in a complex way, let's say. So another way, just simple way to reduce obscurity is to avoid optional parameters. That I'm not saying that we should always avoid it, but often we find ourselves wondering about the trade-off, and often for simple things, just like optional parameters, a trade-off favors basically the avoidance of using optional parameters. For instance, if I have a dialog that can be visible animated, most people and also most library in the open source community will say that, okay, visible or animated is an optional parameter because by default, maybe they are false. Meaning, or maybe animated is true, I don't know. And that's the point, that meaning that there is only an implicit meaning in the parameters. And also this is a problem for the discoverability of the props, because for example, if you use TypeScript, you are not warned about missing props, and maybe you even, after using a component for months, maybe you don't know about prop at all. So, and the alternative is, for instance, just to avoid optional properties, which means, as I said, that the props now are more discoverable, because if you don't use it, TypeScript will complain about it. And also, for the consumer of the hook or component, of course, it's going to take more time to write the component the first time, but you can imagine it's just going to take like 10 seconds more to write the visible true or animated false. But in comparison, whoever reads the code, for instance, in a pull request, where you cannot have a TypeScript annotations, for instance, I mean, you don't have a TypeScript information in when you did the code in a pull request, you can see that dialog, for instance, is visible by default animated, and then you can maybe comment, maybe we should not have it animated or visible by default. And it also simplifies the implementation for the component, because we use less operators like the option operator or the null, I cannot even pronounce license operator. So, and generally I think that avoiding using this operator is possible, even if you use a strict TypeScript, is better, because it makes the code easier to read. A code with too much syntax with this kind of operator, I find it often maybe not hard, but I always have to also think about what if the value is undefined. So by making just required, we avoid all that kind of trouble. And always, also, whenever I see the option operator, I think about this in the office. And of course, I love Michael Scott, but I don't want Michael Scott to write my code. So another way to reduce obscurity is, for instance, to use the so-called discriminated union types in TypeScript. I'm not going too much into the details of this because Stefano is going to deliver later another talk going deeper about this topic. So the idea, for instance, is that if you have a state or prop, whatever value, typed as a shipping address, maybe you are delivering an Amazon delivery, so you can basically deliver to maybe a name, street, and city, and so on. But maybe you can leave it to a pickup point. So to allow that possibility, which is optional, so you add we typically add a boolean like is pickup, or we add a property called the pickup company, which is optional because if you are like delivering to the home, there is no pickup company like a DHL or Poste Italiane. Hopefully not Poste Italiane. And the same goes for the payment method, which maybe often we can just define as a string. And the problem with this kind of type definition, for instance, is, as I said, for instance, you can write is pickup as true, but forget to set pickup company as a value. Or otherwise, you can have even invalid states. For instance, is pickup maybe false, but pickup company is still defined. And this kind of rule should be, nowadays, be easy to enforce in a type system, right? We are not like writing in Java with the nominal type classes. We are writing TypeScript. And this is indeed possible in TypeScript. So, and this is called using discriminated union types. There are different names for it. It's called also sometimes in functional programming, also union tag types. So there are different names, but the pattern is very simple. And the idea is using, for instance, a property called kind, which allows TypeScript to basically discriminate between send to home type or send to pickup point type, meaning that, for instance, for the send to home, I don't need extra properties other than the common ones, whereas with the send to pickup point, I need, you can see that this is now required, the type and the value for company. So this basically save us the possibility of having invalid state. And also, then when you write any kind of function using this value, you can have a so-called type narrowing. So for instance, if I try to access the company property, it's going to return error because it's not defined in the sender to home member of the union. Whereas if I check for the kind of property, type is going to able to do the so-called control flow analysis to basically infer that then in this branch, the only possible case is basically the send to pickup point member, meaning that, sorry, send to home, so the company is always not defined. On the contrary, in the other case, it's always defined. So again, for instance, this saves the usage of optional operators. And then we can even assert that, for instance, it's not possible to reach the case that, for instance, at the end of those if branches, we still can access address company. The address company type will be narrowed down to never, basically the empty set, meaning that's impossible. And this means that, for instance, if tomorrow we need to add a new member of the union, a new shipping method, TypeScript will automatically give us an error saying that here, now, address company is not never, but it's the new method, meaning that the certain reachable code will basically throw an error in TypeScript because it takes a never parameter, so it cannot ever happen. Okay, so we talk about obscurity. We have seen different examples of obscurity and how it can just be avoided using a better types or just using less optional parameter or even just in JavaScript the default values for function parameters. Now we talk about the lack of composition. That's also a great cause of troubles in our code base. And that's because composition is at the core of how we program software. And this has been well known, for instance, in functional languages that are really based on the whole idea of composition. And also, if you think about React, one of the main concepts in React is how easily it is to compose components compared to other solutions we had in the past in the JavaScript community. So, for instance, we can try to write a component model where you can accept the children for the model content, and then maybe you find out that you need to maybe add some header or content or header label to the content. So you can, for instance, just do that with some string property. The problem is that maybe later you find out that you want just to have that text in maybe bold text or just maybe in a different color. And those string is gonna come really not helpful with that. And that's because strings are not like really composable. You can join strings, concatenate strings, but there's not much you can do with strings. And by just, for instance, preferring other kind of constructs like functions, generally functions in programming, especially in JavaScript, are much more composable than anything else, like strings or even objects. That's also why we moved from class components to hooks, because hooks are functions. And compared to classes, which are, technically functions in JavaScript because of how prototype works, but in practice, they don't compose as functions, class instances. So for instance, we can, at first, just use to support a function, and you can see already, by simply supporting function instead of string, you can already give a much flexibility to the props and to the customization. And as I said, this is because functions are more flexible and more composable than strings. But then we move to a different pattern. For instance, this is from React Bootstrap. And this is also pretty familiar. You can see in this case here, instead of just having props, you can have different components. And since components are functions, even more composable than simple functions because they are like special functions components. And you can also see that in this code, the amount of code that you are writing is much bigger, the quantity of code. But in my opinion, this is more flexible and also less obscure than this version here, especially if you want to have heavy customization, for instance, on the text of the header. And this has been a good trend in the past years in the React community. Instead of having complex props in components like model or data visualization, we prefer to have libraries which offer many lower level components that can be composed together to achieve whatever you need. Of course, the implementation of the model is going to be a little bit more complex. For instance, it's going to use like a React children map or colon element. But for a consumer point of view, it gives much more flexibility. And for instance, React Kit, now called Aria Kit, a week ago, things changed very quickly, is also a good example of this. For instance, is a UI library that gives you basically very low-level components, only meant specifically for accessibility and without much skinning. But it means that, for instance, they have great composability because, for instance, they export both the components you can use, but also the hooks for the state so that you can compose your own components. For instance, here, I just create a simple example from the documentation where I declare the state from a hook, meaning, for instance, that this value dialog can be used in other hooks in my component, compared, for instance, to the example here, which was already good, but I cannot use maybe props in other hooks because I don't have hooks from a React strap. I only have components, whereas here I have even components for the state and hooks for the state, and there are even hooks, for instance, for the accessibility props. Okay, this means, for instance, that I can simply write a new composed hook called use delay dialog state, which is gonna call underseen the hook from the library or for our own components. And in this case, I'm just adding the possibility to add a delay so that, for instance, opening this dialog is going to be delayed. So I can just call the hook and then return object, which is going to spread the values. So spread, for instance, is a great utility in composing objects. For instance, Angular doesn't support the spread the props in the template. That's why I don't like Angular. and then again, you can see the pattern all over again. Toggle is a new function that, for instance, internally is going to call the disclosure toggle. So we are composing a new prop, which is a new function, just a new function composed by using the underlying function disclosure.toggle from the use dialog state hook. So you can just use the function to compose. And then we can just use the new hook as before. So you can reuse the existing components combined with a new hook, meaning that when you have lower level components which are more composable, you can compose them in different ways to achieve a great flexibility in the result. But that doesn't mean that you cannot have just this kind of component for the most common case where everything is already included. This is often called controlled components in the libraries we use. Many libraries nowadays offer two versions, the so-called controlled component, which handles the state internally, which is easier to use, and the so-called uncontrolled version, which means that you have to define the state, maybe using the hook from the library, but it gives you more flexibility to build like a special case of a component. Okay, and then adequate is also a good example because it also supports the flexibility by allowing simple patterns like the as prop, which can receive any kind of React element type. So basically a function, a class component, or an HTML string for HTML element. And also, of course, the render prop, which I think all of you know. So also the render prop, again, you can see the whole concept of render prop comes from the usage of a function as a children, because again, functions are more powerful and composable than just a normal children, which is like a string or an element, React node technically. So, and with this, we can see that basically the components of a project basically can be seen as inverse pyramid, where at the bottom we have very low-level hooks and maybe accessibility hooks, like user disclosure or disclosure for disclosable content, which is just things that can be shown and hidden. And then you can start to build components on top of it, like a dialogue, an accessible dialogue, which is going to just be animated and be visible or hidden. And then on top of that, you can have finally your own themed components, like the one you use in the company and are used by different teams. And then finally, you can have the business level components built on top of the lower level components. And this pyramid, in my opinion, is inverse because you need to be careful about the lower levels of the pyramid, because these hooks, for instance, are going to be used by many more components, which in turn are going to be used by many more components, and in turn again. So this means that, for instance, if there comes an issue with accessibility with a tutor profile model, it means that it's going to really be difficult for them to solve that accessibility issue, because the issue maybe is in the underlying hook not working correctly. So we have to be very careful. The more the components used, the more it's lower level, the more we have to be careful about any kind of even simple decision we need to make. For instance, just to decide what kind of props to spread down and that kind of decision, or whether we want to use optional properties. Those kind of simple decisions can have a great ripple effect in the whole code base or even the company, let's say. Okay, so we talked about also composition components, and we can apply the same logic of composition to other problems in a code base in an application. One of the biggest problems surely is handling effects. The problem with effects is that effects encompass a great number of different things, like just changing a variable, or listening, or changing the DOM, or for instance, in my company or in software like Fima, we also have to handle effects which are canvas mutations, or to listen to canvas changes. And the most common one is gonna definitely be data fetching and revalidation, but you can also have more complex stuff like WebSocket or WebRTC connections. And for this is a simple example, just to get started. Everyone on the same level, we're using the use effect. Use effect is the tool that we use everyone to handle all these kind of problems, and that's because use effect is meant for any kind of effect. And that's something that's going to come back later. In this case, we just run an animation with a request animation frame, which is a DOM API, so we need to use a user effect, okay? Now we talk about API effects, which are maybe the most common troublesome issue. So if I want to get, for instance, the user profile information, I can define a state, and then I can use use effect to basically, first of all, I need to be careful about the dependencies. So there's something already need to be aware. And then I can, for instance, just get the value and put it in the state. Easy, right? Then things become more complex because you need to handle all the different states. Actually, the loading can be in. We have learned about union types, and so in this case, for instance, this is very similar to how React Query defines its type. You have union type, so you can have the loading is true, profile undefined at first and are null. Then use loading becomes true, but you still don't have the data. Then maybe if everything goes well, you have use loading is false, and you have now the data and no error. Otherwise, everything is false and defined, but you have error. There is even actually another state which I haven't included, which is when there is an error while refetching. If you are refetching, it means that at first the data was successful, so you have some data that can be shown, but now you are refetching, and the refetching went into an error. And that's the problem with effects. So effects are complex because they interact with the real world. So there are many ways they can go wrong. Maybe messages are arriving out of order. They are maybe duplicated, especially in the microservices and this kind of more complex world we live in. So, and then we also have to manage this state carefully in use effect. And so it makes, as you can see, the code much more obscure immediately by just having all these more states to take into consideration. So then you start to Google how to solve these kind of problems, and you come into React Query. You find out that you can just write use query, where you first define a list of dependencies. They are technically called query keys, query hash, but they are just the same dependencies as the use effect hook, just with a different name. And then you can pass your function to request the data, and in turn, use query is really powerful. It's gonna give you all the states where your single query can be. And it's a really good library. I've been using it a lot, and I like it a lot. So that query solves lots of problems with the data fetching, like caching, retrieval failure, data invalidation. So it's a really, really good tool. I think there's a good reason it's really used nowadays. And unfortunately, though, React Query, in its nature, is just user effect basically for data fetching on steroids. And you can already see that, for instance, as I said here, it's accepting as a first parameter the list of dependencies just as a use effect. So of course, it's going to handle internally all data state, but basically in its nature, it's not really a game changing. And we can immediately see that if we start to talk about dependent effects, meaning, for instance, you want to request a user project after you have requested a user profile. So we know that if you use effect, you need to basically you be careful about the dependencies of each effect, and carefully add a check to the second effect so that it runs only when the first one has completed. And oh, sorry, the wrong slide. And so the problem with the use effect is great because it takes dependencies. It means that whenever any of the dependency change, basically you can rerun the whole effect. And compared to class component, is a much superior, at least in my opinion, way to handle effects. Because the idea of effects is that you don't need to worry why the dependencies changed. You just need to rerun the effect, and it's going to take care of the whole life cycle of the effect, both the running the effect and also canceling the effect. This is much better than splitting the life cycle into several methods in class components. Unfortunately, for use effect, I think it was more meant to be used as a low-level block for handling any kind of effect, as we know you also use it for DOM changes or any kind of effect. But for instance, I don't think we would use effect for starting a WebSocket connection, because in that case, you need to be even more careful about dependencies because you don't want to rerun the WebSocket connection, because even though the pattern looks cool of rerunning the effect whenever the dependency change, since effects have consequence in the real world, they are not just simple calculation. Establishing, for instance, a WebSocket connection is expensive in terms of network cost. And when you have dependent effects, basically what you need to do at the point is to add guards to your effect, so that, for instance, the second effect is guarded by the return result of the first effect. So the return result of the first effect is going to be both a dependency and a guard of the second effect. And whenever any of the dependency change or the guard is true, so the guard is basically like a special dependency, we run the effect. And when you have more than one dependent effect, things start to become really complex. And as we said, the problem is that it's difficult to basically compose effects together. And especially if you have like 2 or 3 effects, you can easily run into issue that maybe this effect is going to return a value that you don't know is taken as input of the first effect, meaning that when the first runs, the second one is going to update, the first is going to update, and then the return value is going to trigger a new update in the first one, and in basically an endless loop. I know you're familiar with this. So let's see how, for instance, useQuery tries to solve that. To solve that, useQuery says, OK, you can use the enabled property, so that if the enabled property is false, the query is not gonna run. And you can see that when I say that useQuery is just use effect, you're seeing that here it's using again a guard. So it's not using a new way to solve the problem. It's using the same concept of a guard, just disguised as a config object. And this, in turn, for me, it means that this code is, for instance, more obscure than maybe just using an if condition, because you need, for instance, to know about how this property works in a React query. If you're maybe a junior developer, maybe this is the first time you are using useQuery and you didn't know even about this property. And also, for instance, TypeScript is going to complain because when you try to request the data, it's going to say the project ID can be undefined or string. And you know that in JavaScript this is fine because there is actually a guard here, so you know that by the conventions of React query, this is not going to be defined when this function is called. But TypeScript doesn't know that because there is no control flow information in this code for TypeScript to deduce that this value is not going to be defined. And in my experience, often when TypeScript complains about stuff, and it always has a good reason for that. And it often means maybe that we can program the software in a better way, or at least try to do so. For instance, if we had used if, at least, we would have had the normal control flow analysis. So you see the problem with the libraries is that they often gives you more power using objects, but by using objects, for instance, there are less composable the functions, and they give you more trouble to TypeScript, to the control flow analysis of TypeScript, because you are doing something different than what the TypeScript typically expects. And TypeScript is already a really powerful type system. I think the most powerful one in the mainstream languages. And then you think about promises, and you really miss those days where you could just use promises. So for instance, if we could use promises, we could just use async await, right, to have dependent effects. I mean, one run each other. That it shouldn't be that complicated, right, to run an effect after another one. And that's because promises compose actually really well, and that's the whole point of promises. They, for instance, have been introduced in JavaScript to compose better, to have a better management of async events compared to callbacks, and that's a different style. For instance, if we wanted to make things a little bit more complex, for instance, instead of asking for a single project for the user, asking for a list of projects, or of all the projects of the user, we can just use a map. So it's just JavaScript. For instance, TypeScript is going to be really happy about this because he knows how to analyze this control flow. And then we can just use the promise all function to compose an array of promises and just to use await. So again, it's really simple. But the problem with the promises, first of all, we cannot use them in in React components directly, at least so far. But promise, unfortunately, compose while only for the happy path when things go as you expect, like everything is coming back from the server as you expect. But the problem with, as I said, with effects is that they interact with the real world, and so they go wrong. So you need to take into account stuff like effort cancellation, retries, and race condition, which are really tough to write with the current state of even async await or promise. With async await, it's easier because you can use a try-catch block, but it's still maybe not that easy. And you cannot use that in React components. That's the whole point. So for instance, it would be cool if we could use just map with the use effect, maybe. So if you have a list of IDs, it would be cool if you could just use map with the use effect. Unfortunately, we cannot do that because hooks, even though they are functions and they are more composable, as I said, the class components, they are still not that much composable because of the rules of deterministic rendering. You cannot use if, you cannot use loops, and if loops are the main blocks of how we program every day and how TypeScript works. So for instance, React Query introduces the use queries hook. So I think also it has happened often to you that you write a hook, a custom hook, then you later discover that the hook is gonna need to take more than one single parameter. So you need to maybe to make the hook work with an array of values instead of a single input, or maybe make a new hook. And then the new hook is probably gonna have to implement a lot because in the new hook, like use queries, you cannot do internally a map of use query because your hook, custom hook, is gonna have the same rules of any kind of hook. And for instance, in the React query community, you have to return an array of query configs, which again is much more obscure as a code than just doing a map. For instance, you have to be careful about the stale time because every time a request arrives, there will be a new render, and you don't want, for instance, to refetch the already received request. And that's because, for instance, by default, React Query has a stale time of 0, meaning that whenever you request again an API, it's going to reuse the value that it already has, but behind the scenes, it's going to try to fetch a new value and consider it as a fresh because the default value of stale time is 0. So you can see that this is some very implicit stuff that most of people don't know about, or it's hard to remember when using use query and agree. And so this is a good example of increasing obscurity. So what else can we use? We can use, for instance, observables. For those of you who come from Angular, for instance, or there are other patterns like generators. I don't want to go into details of this, but there are different patterns, maybe more powerful, but they are also more complex to manage, learn. They have, for instance, observable, a much steeper learning curve. So it's not different. It's not really easy. And the way I see all these kind of libraries is basically the fact that nowadays we all have these different solutions, and that's because, as I said, affect is a very broad term, so that encompasses a lot of kinds of affects. So it means that, for instance, you can use Redux Saga, but also use just use affect. And use affect is the lowest level block that you can use to any kind of effects. Then you can use libraries like React Query or React Router to handle, or Remix to handle the data fetching, and they are really good in what they do. They're just really good at specifically one thing. Like React Query is really good at handling one single request. So okay, so this means that, for instance, personally, I like to use effect for synchronizing any kind of DOM change, and use query, for instance, for a single standalone API request, and the sagas for orchestration. And the term orchestration, for instance, is something that's missing from the other libraries. And maybe that's going to change in the future. For instance, a week ago, we have a new discussion about the first-class support of promises and async await in React. This is going to introduce a new hook called use. That's why I had a slide that I expected people to write to Google how to use. And now you can see that with use, you can accept basically a promise, and it can also be used conditionally, like in this case, within the if. And this is really powerful because it seems a lot that, for instance, maybe we can write this. So if you have dependent effects, you can just pass the first promise, and then the component will be paused until effect is run, and then you proceed to the next promise. Or maybe you can, since it can be run conditionally, maybe we can now run the map. So you can map a list of IDs and just return a list of use. Okay, so we have seen what complexity means, what obscurity and lack of composition result. So to conclude the talk, when writing for code, we need to design for composition to ask ourselves how our result is going to be more composable. Whereas when we pick a tool like a library, we have to wonder ourselves if it's going to help us compose better. And then we discussed about composing components effects, but there are other kinds of composition like types or errors, which are not in this talk, maybe next year. So stay tuned for that. And that's it for me. And by the way, my name is Jiayi, and so have a nice conference.